Lastly, let us look at the indeterminate form, either 0 raised to the exponent of 0, infinity to the exponent of 0, and 1 to the exponent of 0. All these are indeterminate forms. You cannot say that 0 raised to the exponent of 0 is 1. There is no such thing. Or infinity to the power of 0 is 1. Or 1 to the power of infinity is 1. On the surface, it appears as if it's trivial, but it is not. So we don't really have time to explain to you why it is not like that, but you may find out that indeed this is not equal to 1, this is not equal to 1, this is not equal to 1. So again, let us illustrate how we work with these indeterminate forms via some examples. The first example we will evaluate the limit of x raised to the exponent of x. X is approaching 0. Say 0 from the right. Now, direct substitution, indeterminate form, type 0 to the exponent of 0. Then how do we deal with this? We let y to be equal to x raised to the exponent of x. Then we introduce ln on both sides of the equation because we want to deal with this exponential function. So we have ln y equal to ln of x, the exponent of x, and then we apply the law. It's ln y equal to x ln x for that matter. So tells us that the limit x is approaching 0 from the right of ln y equal to the limit x is approaching 0 from the right x ln x, just like what we did previously. So, well, you can make it longer and repeat what we have just done for those who want to watch the previous video, but this has been covered in the previous video. So this is the limit x is approaching 0 from the right, because this is 0 times infinity. This is type 0 times infinity. So since it is like that, then we'll write limit ln of x divided by 1 over x. Substitute. This is type infinity over infinity. And then we differentiate, or we apply L'Hopital's rule. X is approaching 0 from the right. It's 1 over x over minus 1 over x squared. And then when we simplify this, this is the limit. X is approaching 0 from the right. Then we get minus x, which is going to give us 0. So this is telling us that the limit when x is approaching 0 to the right, from the right of ln y, which is the same thing as we have seen, is the same thing as the limit of x ln x. X is approaching 0 from the right. This is equal to 0. That's what we have seen. Now, there is something we discussed when we were looking at natural exponential functions. We know that y equal to e to the ln of y, isn't it? When this base and that base are the same, then we have that. So, and the exponential function is continuous. So from continuity of the exponential function of the exponential function, what do we observe? We have that, we have that if we talk of the limit of x raised to the exponent of x as x approach 0 from the right, this is the same thing as talking of the limit x approach 0 from the right of y, isn't it? Because we said this is equal to y. So if we do that, then from this observation here, we can say now we are talking of the limit x is approaching 0 from the right. Our y can be written as e raised to the ln of y, like that. And now, because the exponential function is continuous, this is telling us that this is the same thing as e limit of ln y when x is approaching 0 from the right. What is the limit of ln y when x is approaching 0 from the right? We have that this is equal to 0. So we have e to the power of 0, which is 1. Then another example, we take evaluate the limit x is approaching 0 from the right. You have 1 over x to the power of sine x, like that. And then you will observe that if you do direct substitution, this is type infinity raised to the power of 0. So if that is the case, you let y to be equal to 1 over x the power of sine x, like that. Then you introduce ln on both sides. So you have ln of y equal to ln of 1 over x, the exponent of sine x. Ln of y equal to sine x, ln of 1 over x, like that. And then if that is the case, then when you evaluate the limit x is approaching 0 from the right, ln y equal to limit x is approaching 0 from the right of sine x times the ln of 1 over x. Now this will be 0, this will be infinity. So 0 times infinity. So we have got type 0 multiplied by infinity, like that. So don't forget, we want to write this in such a way that we end up with infinity over infinity, or 0 over 0 for that matter. This is the limit x approaches 0 from the right. This can be written as ln of 1 over x, or simply minus ln x over 1 over sine x for that matter. And when you substitute 0 here, this will be infinity. Substitute 0, this will be infinity. So now we have type infinity over infinity. Now that we have infinity over infinity, we can apply the L'Hopital's rule. Maybe before that, easier to make life to work like this. This is minus the ln of x divided by 1 over the sine of x. And if we have something like that, then it will be equal to the limit. X is approaching 0 from the right. Then you differentiate, you get minus 1 over x. You differentiate 1 over sine x. What do you get? Derivative of 1 over sine x is the same thing as the derivative of cosec x. The same thing as the derivative of cosec x. But anyway, we note that the derivative of 1 is 0. Can apply quotient rule here. Derivative of 1 is 0. 0 times sine x is 0 minus, then the derivative of sine x is cosine of x. Divide that by sine squared of x, like that. Of course, this will give us the limit. X is approaching 0 from the right. 1 over x can be rewritten properly because we are dividing here. You can end up with sine squared x over x cos x, like that, which is the limit. X is approaching 0 from the right. This can be written as sine x over x times sine x over cos x, like that. All right. Then since we are evaluating the limit, we are ending up with the limit. X approaches 0 from the right. Sine x over x times the limit. X is approaching 0 from the right. If we want, we can talk now of tangent of x. So this one is familiar, or we differentiate still the same thing, but we can use what we are familiar with, which will give us 1. This will be 0, so the answer is 0. Therefore, we have that the limit as x approaches 0 from the right of 1 over x, the power of sine x, is the same thing as the limit as x approaches 0 from the right of what? Of y. And what is that? This is the limit as x approaches 0 from the right of what? Of e to the ln of y. And what is that? This is the limit. No, this is e, the limit of ln of y when x is approaching 0 from the right, because of the continuity of our exponential function. And this is equal to 0. So we have got e to the power 0, which is 1. Right. Therefore, in other words, we have concluded that the limit when x is approaching 0 of 1 over x sine x is simply 1. It's simply 1, like that. Finally, let us come to this famous one. evaluate the limit when x approach infinity of 1 plus 1 over x raised to the exponent of x, the exponent of x. So we will observe that if we do direct substitution, this will be 0. So this is type 1, the infinity like that. Okay, so again we let y to be 1 plus 1 over x, the power of x. Then you may guess what is going to happen next. We introduce ln on both sides. We have x, the ln of 1 plus 1 over x, like that. And then we try to check limit x is approaching infinity, ln y equal to limit x is approaching infinity, x, the ln of 1 plus 1 over x. And then we check what do we have. This will be 0. Yes, this will be 0. This will be 1. Ln 1 is 0. This will be infinity. So basically we can write that we have type 0 times infinity, or infinity times 0. Maybe I should write infinity times 0, because that's how it looks like, and that is indeterminate form. So this is the limit, x is approaching infinity, ln of 1 plus 1 over x divided by 1 over x, like that. Then what type? This type, if you put that, this will be 0 over 0. So we have got type 0 over 0 for that matter. And then we evaluate, we have the limit, x is approaching infinity. Then we differentiate this, which will be 1 over 1 plus 1 over x times the derivative of this inside function, which will be minus 1 over x squared. Divide everything by minus 1 over x squared, like that, right? This and that are the same, gone. So we're looking at the limit, x is approaching infinity, of 1 over 1 plus 1 over x. When you substitute infinity here, you get 0. So this is 1 over 1, which is 1. Then again, we have now the limit, x is approaching infinity, 1 plus 1 over x, the power of x, equal to the limit of y when x is approaching infinity, which is the limit of x approach infinity. Y is e to the ln of y from continuity of our exponential function, which is the same thing as e to the limit of the ln of y x approach infinity. And what is this? We have shown that this is equal to 1, which is e to the power of 1, which is e. And this gives us something very important, because sometimes we say the limit of 1 plus 1 over x raised to the exponent of x as x approach infinity, it's equal to that beautiful number e. That's the proof